Hello and welcome again as we consider yet another multiple choice question for IB chemistry. What is the number of optical isomers of isoleucine? And here you have a skeletal formula for isoleucine. So there are a couple of things you need to do in this question. First up, you need to understand the meaning of this formula here. And then of course you need to know what optical isomers are. Now, if you need to know all about optical isomers, you can click on the card above. But assuming that you do know what optical isomers are, it means you'll be looking at this structure and you would be looking for chiral centers. A chiral center, of course, is one where you have a carbon attached to four different groups. Now, we also need to unravel this skeletal formula, and you should understand that we do have a carbon here, and a hydrogen also attached here, carbon making four bonds always, a carbon here with a hydrogen attached here, carbon here attached to two hydrogens. So we then look for where we have carbons attached to four different structures. And this one here, CH, C attached to all of that, C attached to NH2, and this C attached to all of this. Then we have another one here, C attached to a CH3 up here, attached to an H, and these two different groups on either side. Whenever we have chirality, it gives rise to two optical isomers. But those two optical isomers, which we could just call D and L for now, arise with respect to each chiral center. So therefore, if we have one chiral center here, it means we have one pair of optical isomers, D and L. But this center is independent of this one. So it means you could have, for this one, also a D and an L. And when you have two Ds, you'll have one isomer. When you have a D and an L, you'll have another isomer. When you have the L here and the D here, then you'll have another isomer. And when you have two L's, then you'll have another isomer. So there are four different combinations that you can get, because each chiral center can give rise to a pair of optical isomers. And when you look at the different combinations, you'd realize that the answer should be C, 4. Of course, there is a short way to do this, which is not explicitly included in the IB chemistry guide. But now that we see a question like this, it's useful to have this formula at hand. And the formula says if there are two chiral centers, then we go 2 to the power of 2, and you get 4. If you happen to have three chiral centers, then you go 2 to the power of 3, and you end up with 8. If you want, you can try that out if you have three chiral centers and look and see how many combinations you would get. But you would expect to find 8 if you have three chiral centers. And for this question, with the two chiral centers, 4 optical isomers.